So I want to end up basically just kind of hitting some of the big points and a little bit of review for the test of this class. So this is the final lecture of Psych 221. And again, the core goal of Psych 220 and 221 is basically to introduce you to the ideas of the methodology of research, the terminology of research, and the functional tools, statistics of research. And we started looking at basically correlational research, where we were simply looking for the relationship between two variables, generally two continuous variables. And though we would dub one an IV and a DV, a predictor and an outcome, the big thing to remember there is that correlation itself, finding a statistical relationship, does not imply causation. And it's not just that correlation does not imply causation. P-values never imply causation. And causation is not a statistical issue. Causation is a methodological issue. And again, the generally most correlational research is missing temporal precedence, where you've controlled your independent variable, and control over that independent variable often through random assignment, which means that you have potentially extraneous or confounding variables. And a confounding variable, again, is simply a variable that varies with your IV that might also influence your DV. When we talk about experimental research, we're talking about trying to take direct control and manipulation of those variables. And again, this is not a statistical technique. This is a methodological technique. We are manipulating the independent variable. We're controlling it. We're introducing it. We're adding a treatment. We're assigning people to conditions. And therefore, we know that it comes before our outcome. So we have that temporal precedence. Our cause, our IV, comes before our effect, the DV. We manipulate that independent variable, we create different levels or conditions, and allow one to determine the order of effect. And then we measure our dependent variable. Now, the big advantage here is we tend to control or eliminate extraneous third variables if we can make the argument methodologically that the only thing that changed between our conditions was whether or not someone was introduced to that independent variable or not. Now, when we're measuring variables, again, I want to just briefly review. These are like the big main points that I want to make sure you remember. We do need to know how we measure that variable. And we need to know, was it nominal, otherwise referred to as categorical? And categorical only has identity. Basically, it is a categorical variable, is a variable that we have no real mathematics attached to the numbers. The numbers are just names. Ordinal variables are ones where the names now have order, but we don't know if they're actually equally distanced. In other words, the distance isn't meaningful. Finally, we have interval, which is what we typically want to see in most of our measurements. We have the numbers have an ordinal or magnitude relationship, and we have approximately equal intervals between them. We actually do have one rank of scale above the interval scale, and that is ratio. And that's basically count data, time data, things where zero actually means zero. Remember that in an interval scale, even though the numbers have magnitude and equal intervals, they're often still somewhat arbitrary. A 1 to 5 Likert scale is 1 to 5 because we decide it's 1 to 5. It could be -2 to +2. It could be 10 to 15. The numbers and the distances are represented, but there really isn't a meaningful zero. Even if we have a zero, the zero is just another point in the scale. Ratio data adds absolute zero, meaning that zero means zero. Zero actually represents nothing of the construct we're interested in. And again, for our purposes, we generally want to see nominal or interval or ratio scales. If it's a nominal scale, we treat it as a categorical variable. If it's an interval or ratio scale, we'll treat it as a continuous variable. And most of our statistical techniques require us to know which variables we have that are categorical and which variables we have that are continuous. We want to remember that normal distribution is such an important part of any continuous variable that we're reliant on it. Almost all of our statistics assume a normal distribution, and our statistics are rarely using the entirety of our data set. They're usually using the means and standard deviations to make their comparisons. And if we don't have a normal distribution, those means and standard deviations are, pardon the pun, less meaningful. We also talked about how to convert any score into a z-score, which basically puts 0 as the mean of the distribution, and positive or negative values being the units of standard deviation that the person's score was above or below that mean. We talked a lot about statistical significance, and I really kind of tried to really pound home the concept, if you will, that statistical significance really is simply a measure of probability. That we're basically wanting to determine, we're wanting to go through a process to determine how probable is it that the results that we found in our study could have occurred due to just random chance or noise. And that we've set kind of a criteria for this. And that for every statistical test, we're going to go through these 5 terms, and this is terminology. We're going to have the obtained test statistic, and that refers to the actual value that we calculate with that particular statistical test. We're going to compare that obtained test statistic to a test statistic probability distribution. And this is basically a distribution of numbers that indicates, based on the power or the number of participants and number of variables we had in the study, which is usually referred to as degrees of freedom, or DF, what value do we need on that obtained test statistic for us to be able to be sure that it would have occurred by chance less than 5% of the time. The critical test statistic is what we gather from the test statistic probability distribution. It is a set value that the test statistic has to be higher than to indicate a systematic effector relationship. So whenever I'm actually running a statistical test, I'm going to get the value I calculate from the math, obtained test statistic. I'm going to look at a test statistic probability distribution, and from that test statistic probability distribution, I'm going to select a critical test statistic that my obtained test statistic needs to be higher than. If it is higher than, it refers to the actual p-value of that test, and the p-value is the actual statistical significance. Now, if we're using test statistic probability distribution charts, this value is going to be estimated. However, in a lot of advanced statistical computerized packages like SPSS, we will actually be given the actual p-value. What is the probability that this particular effect or relationship could have occurred due to just random chance? And the alpha level is our marker of what p-value will we accept. And in this case, in the psychological sciences, it's pretty much been set standardized at 0.05, or 5% chance of being wrong. We talked about broadly that when we're doing research, that it's easy to focus on the methods and the statistics, but we also need to make sure those methods and statistics are drawing on previous research, are asking intelligent questions, and are basically not reinventing the wheel. They're building on what's already been known. And this is the hourglass notion of research, that we start very broad with theory, broad open questions, focus on past studies, the lit review. And the purpose of the lit review is to summarize what is already known and to basically broach what's unknown. What is our research questions, which leads to our hypotheses. Our hypotheses are then going to drive our operations and our methods. So the methodology of the study, what methods are you going to use to ask or basically try to answer this hypothesis, test this hypothesis. We're then going to conduct the observations and collect the data and analyze the data. This is going to be the results section. Once we have our results, we now go to the discussion section where we're actually going to try to make our conclusions and then generalize back out from the specifics of our study to the broad theory and questions that we asked at the start of our study. Now, internal validity, whether the study is internally valid or quote-unquote trustable, is in our methods and our results. External validity, can we actually generalize what we found in our study to the population at large, is external validity. So again, the APA style paper, a major focus of both 220 and 221, has been in both reading, understanding, interpreting, and writing your own APA style paper. We want to familiarize yourself with APA style, and APA style includes reading and summarizing previous research, creating questions that are logically supported by that previous research, communicating those methods that you used, presenting your results objectively as possible, and interpreting the results back into the research, both past and future, while properly citing and avoiding plagiarism. And again, we kind of talked about how do you identify an empirical article. And again, some of the things that we mentioned that you can quickly do is, does it have an abstract? Does the abstract include an N, in other words, the number of participants in the study? Does it clearly identify the authors and who their affiliations are? And does it come from an article that actually has both a journal title and a volume number? If you have all of these factors, you can be pretty sure that it's an empirical article. If it's missing any of these factors, it may not quite be an empirical article. It may come from an empirical journal, but it might be a thought piece or a theoretical piece. So we talked about the various types of design methodology and ways to categorize design methodology. We talked about the first question is basically whether you have random assignment into groups or whether you're even comparing groups. And again, if you have random assignment in groups, you're probably in an experimental type of design. If you're comparing groups but you don't have random assignment, you're probably in a quasi-experimental design. And if you aren't even in control of the groups, you're just looking at one particular state of data across a group, you're probably in a non-experimental design. The next question we can ask is, do you have a single independent variable or multiple independent variables? If you only have one, you're in a one-way design. If you have more than one, you're in a factorial design. And finally, you need to ask that if you have groups that you're comparing, are the different people in different groups between participant design? Are the people that are in your groups the same people being exposed to different levels of your IV within participant design? Or potentially in a factorial design, you have a mixed design. In some categories, some IVs are between participants and some IVs are within participants. Each of these designs have their strengths and weaknesses, and it really is an important thing to be able to categorize because some of these will give you an idea of how to generalize the information, and specifically whether it's a one-way design or a factorial design, and whether it's a between participant, within participant, or mixed design, are going to help you very much decide what kind of statistical technique is appropriate for the data that you have. Now let's talk about the actual techniques that we covered. We talked about Z and T, and basically we use Z when we actually have information that we are looking at. And again, what we need to know to use Z is the population's mean and the population standard deviation. And then, of course, obviously, we're going to have our sample information. We're going to use T when we only know the mean of the population, but we actually have a larger number of N, and in that case, our sample size, and the sample size is less than 30. So for example, to run a Z-test, I need the population's mean and standard deviation, I need the mean of my sample, and I need 30 or more people. If I'm using a t-test, and this is again for single samples, where I'm comparing one group to a previously known value, I need to know for the t-test for single samples, what is the mean of that population, but that's all I need from the population. But from the sample, I need everything. I need the mean, I need the standard deviation, and I need the N, but the N can be below 30. So generally, if I have over 30 participants and I have both population, mean, and standard deviation, I'm going to use the t-test for single samples. If I don't have that population standard deviation, or my N is less than 30, I'm going to use the T for single samples. And again, when we're looking at the t-test for independent versus dependent samples, and this is actually not the t-test for independent samples, this is actually a t-test where we have two groups and we're comparing them. I want you to remember that the main difference here is basically, is it a between or within subject design? If it's a between subject design, different people in each group, we have independent observations, while if it's a dependent sample, it's the same people in both groups, we have dependent observations. But other than that, the where you'd use this test, categorical IV with a continuous DV, and that categorical IV only has two levels, would be the same for both of these tests.